Okay, in this video we're going to look at the section 1.6, and that is the transformation of functions. And our objectives here, we got 7 of them. Recognize the graphs of the common functions. Use vertical shifts to graph functions, horizontal shifts to graph functions, reflections either about the x or y axis. Look at vertical stretching and shrinking of graphs, and then use these horizontal stretches and shrinks to graph functions, and then graph functions involving a sequence of all of these different transformations. So here are the common graphs. The first one is just a constant, like y equals 1.5 or 1 3/4 here. You just have a horizontal line at that y value. F of x equals x. That's just a common slanted line going through the origin. Slope is 1. We got our absolute value of x. That's the v-shaped graph that goes through the origin if it is not shifted. We got our common parabola, x squared, goes through the origin, opening up. The square root of x, that starts at the origin and only goes out into the first quadrant unless it's shifted. Here's our x cubed. When we cube a positive number, we're positive in the first quadrant. But when we cube a negative, we are down negative in the third quadrant. And then we have our third root of x. It looks a lot like the square root that starts going up here into the first quadrant, but since we can cube negative numbers, we do have this piece that goes off into the third quadrant. The cube of a negative is a negative, so that puts us down in the third quadrant. So vertical shifts is where we're going to start. You know, if we have a function like f of x, here is our variable that is in the parenthesis. You'll either have a plus or a minus outside of any grouping symbols. So the book says let's begin by looking at at 3 graphs whose shapes are the same. The figure shows these graphs. The black graph in the middle is the standard quadratic. F of x is x squared, so that's again the one here in black. Now look at the blue graph on top. The equation of this graph is the same x squared, but we've added a plus 2. It adds 2 to the right side of that equation, so each y coordinate goes up by 2. And we have this other one, x squared minus 3. That means every dot on the black parabola got shifted down 3 units. Instead of passing through the origin, we now pass through negative 3. The rest of the graph is the same. So here's our official definition in the book, our vertical shifts. Let f be a function and c be a positive real number. So the graph of y equals f of x plus c is the graph of y equals f of x, shifted those c units vertically upward. The graph of y equals f of x minus c is the same f of x graph, shifted c units vertically downward. So again, if we have our function here, f of x, the plus or minus the constant is occurring outside of those parentheses. So here, let's take a look at example 1. We have a couple graphs here. The first one, we're going to do f of x is absolute of x. Well, that has 0, 0. Oh, that's right, my software here is having trouble doing dots, so I might just do little x's. The root or the absolute of negative 1 is 1, the absolute of negative 2 is 2, absolute of negative 3 is 3. So here in the second quadrant, we have a line going like this. And in the first quadrant, the absolute value does nothing, so it's 3, 3, 4, 4, 5, 5. Here is our graph of the absolute value of x. This is going to drop everything down 4 units. So instead of going through the origin, we're going to go through here at negative 4, and then we'll have lines of slope 1 and negative 1 going in each direction. So we can just copy the rest of the graph. Close enough. Everything has just been shifted down 4 units. Now horizontal shifts are left-right shifts. If before we had our f of x was here and the plus or minus was outside, this was a shift up or down. Now we're going to see a plus or minus in the parenthesis with the x. So the book says we return to the graph of f of x is x squared, the standard quadratic, the graph of function f in the middle of these 3 graphs down here in black ink. By contrast to the vertical shift situation, this time the graphs move left and right. Look at the blue graph on the right. The equation of this is f of x equals, now it's not just x squared, it is x minus 3 quantity squared. So if we take what is in the parenthesis, the x minus 3, and set it equal to the old 0, where this used to go through the origin, we could add 3 to both sides. Now we're going to hit at 3. So I always think it's sort of counterintuitive. When you see a minus in there, it's going to move the graph in the plus direction to the right. What is that? Blah, 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 blah. If we saw a plus in there, that would just be a shift to the left. So back to the book's graph here, they got a x minus 3 quantity squared. Again, that moved the x-intercept here from the origin to the positive 3. Over here, x plus 2 quantity squared. That plus 2 is going to move us to the left, or in the negative direction 2 units. So we do hit there on the y-axis or x-axis at negative 2. Other than that, the shape of the graphs are the same. So horizontal shifts, let f be a function, c is a positive number, real number. The graph of y equals f of x plus c is the graph of f of x shifted left c units. So if there's a plus in there, it is a shift to the left. On the other hand, the graph of y equals f of quantity x minus c is the graph of f of x shifted c units to the right. Ooh, now what do we have down here? Using my intuition, it seems that f of x plus c should shift it to the right, or the positive direction on the number line, and fx minus c should shift it to the left. Is my intuition on target when it comes to these shifts? No. On a number line, x represents a positive number c, and c is positive. X plus c lies c units to the right. Like I said, I just sort of think of it as counterintuitive. The left and right shifts sort of work backwards from what you would expect on the x-axis, where the vertical shifts up and down make perfect sense. If it's a plus at the end, that is a shift up. If it's a minus, it is a shift down. So here's example 2. We want to graph f of x is the root of x, and then also the root of x plus 5, that quantity. So if we saw the root of x plus 5, if the 5 was outside the radical, that would be a shift up. But since this is all occurring under the radical with the variable, that's what makes this a shift to the left or right. So first let's graph root of x. Here the root of 0 is 0, the root of 1 is 1, the root of 4 is 2, and that's all we can fit on the graph. So our square root graph is going to look like this. And now we want to shift it, the root of x plus 5. So the plus 5 is going to shift us 5 units to the left. So instead of starting here on the origin, we're going to start here at negative 5. And then from our old origin, we would go up 1 over 1, up 1 over 1. So here's our spot. From there, we went up 1 over 3 more, up 1 over 3 more. And you know, this is, if this is our new, so to speak, 0, this is 1 unit away, the square root of 1 is 1. This is now 4 units away, the square root of 4 is 2. We could go, now we have room on the graph, from negative 5 to positive 4 would be a jump of 9, and the square root of 9 is 3. So here's another point on that same graph. And it looks like we have another great question. Okay, I sort of already explained this. What's the difference between f of x plus c and f of quantity x plus c? Again, if this number is occurring outside the parenthesis, it is a shift up, down. If it is occurring inside there with the variable x, that will be a shift left or right. Example 3. We're going to combine some horizontal and vertical shifts. Now, it doesn't matter if we're just doing horizontal and vertical, what order we do those in, but I'm going to plant this seed for later. There is an order of operations for adding in some, PEMDAS, please excuse my dear Aunt Sally. There's also one for doing all these transformations, and I might as well just introduce it now. H, S, R, That's an RV. High school RV. The first transformation you always do would be any horizontal, left or right shifts. The very last thing you'll do will be the vertical up and down shifts. Again, if that's all we're doing, if there are no stretches, shrinks, or reflections, we'll get the answer no matter what order we do these in. But we should follow the pattern. We're going to start that right now. Horizontal first, vertical will be last. So here we're going to do this in stages, and we're back to the good old friendly f of x is x squared graph. So that's going to go 0 squared is 0, 1 squared is 1, 2 squared is 4, and then we're off the graph. And that would also be reflected here on the second quadrant. So there's our basic x squared. So when we look at this, again, high school RV, horizontal, that would be in here occurring with the variable x. That is a +1, so that means we're going to be shifted to the left 1 unit. So instead of starting at the origin, we're going to start here. Oh, let me make these graphs a little bigger. Let me do this. Okay, we did start our old parabola at 0, 0, but now we're at -1. From the old 0, 0, we'd go over 1 and up 1. I can do that from here, over 1, up 1. Now we're going to cross the y-axis at 1, and we're going to go through this point, -2, 1. Come on, why won't this do a dot? From this point, we would go over 1 more, up 3. Because it was the old square root of 2 was 4. Now we're still at a height of 4, but that point has been shifted over. We're going to have one from here, over 1, up 3. So here's our parabola shifted to the left 1 unit. Every point got moved left 1. Now our final shift is down 3. So we were here at this x is -1. Now that's going to get shifted down 3 units to here. And now I can just start plotting the rest of my points. Let me switch ink colors. From our vertex, we'd go over 1 and up 1 in each direction, left or right. So I can do that, over 1, up 1 here. And then we would go over 1 more, up 3. Over 1, up 3. So if I go over and then up 3 more, I have a couple more points. And then I can graph this parabola. And if all you're doing is horizontal and vertical, these aren't bad to do, all at once. Like if I put over here back, get this original f of x. So our shift is going to be left 1, down 3. 3. I know my old parabola, f of x was x squared, would start at 0, so that's going to go over 1 and down 3. And then I would have another point here at 1, 1. Come on. 1, 1. This point is going to go to the left 1 and then down 3. So that'll put that point right on the y-axis. Oops. Over 1, down 3, right at -2. And then my old parabola had 2, 4. This point also goes over 1, down 1, 2, 3. So it's going to land on this same point, 1, 1, on my new parabola. And then I could do a couple more. Here's my -1, 1. That would go left 1, down 1, 2, 3. So that over here on the other graph would be -2, -2. And then I would have -2, 4. That's also going to go right 1, down 3. So that would put me at -3, +1. And I could connect those dots to my shifted parabola. So here's a 2 here to try on this slide, 1 more on the next. So pause the video, try these problems, and then fire it back up and see if you got them right. Okay, let's look at this first one here. Our basic function is the absolute of x. So that's the one that goes from 0, 0, and then we have a line sloped here of +1, another one coming out sloped -1. And now this shift is outside the bars, so it'll be up 3 units. So we're just going to go up 3 units, and here's our, oh, come on. There we go. That's our new vertex, and from here we can go up +1, and this way -1. Second one, we're going to start here with the root of x. So that was the root of 0 is 0, the root of 1 is 1, the root of 4 is 2. And if we go one more block off the graph, the root of 9 would be 3. So there is our root of x graph. Now this is the root of x minus 4. Remember, this is the counterintuitive one with the minus under there. That's going to shift us to the right, or the plus direction. So instead of starting here at the origin, we're going to start here at 4. And then from there we can go up 1 over 1, up 1 over 1. And then from there up 1 over 3 more, up 1 over 3, and that's going to put us at the end of that graph. So we got picked up and moved to the right 4 units. Now here we got a couple different shifts. So root of x, we just did that one, 0, 0, 1, 1. Root of 4 is 2. Root of 9 is 3. So left, right first. So we're going to go inside there with the x, and that is a minus 1. So that's going to shift us to the right 1 unit. So we're going to now have our x axis touching here at 1, 0. From there up 1 over 1. Up 1 over 3 more, and that'll be good enough for this graph. And now we're going to shift each of those points down 2. So instead of being here, we're going to drop down to negative 2 comma 1. This point was 2 comma 1. That got shifted down 2. Now it's at 2, negative 1. And then another way to do this, from that point we could go up 1 over 3. So from here up 1 over 3, that will put us right on the x-axis, crossing the x-axis at 5. That's a good point to nail down an x-intercept. And there's our graph, shifted to the right and then down. Now our next things we're going to look at here are reflections. In the order of operations, we got our high school RV. Horizontal first, reflections you would look at third before we do a vertical, up or down. So here, if we're going to flip it over the x-axis, that means all our y values will change. This y value on the black graph 4 will become a negative 4. This over here also, a positive 4 will become a negative 4. All the y values change. And that's how I remember this, because here we got the graph of y equals negative f of x is the same as the graph of y equals f of x flipped over the x-axis. So here, if we put a negative here, that's like putting a negative here. We're changing all our y values into negative y values. Or if they're already negative, we're going to flip them to being positive. So here, the negative goes outside the function. It's outside the f of x. We'll see later when we put a negative in there with the x, that's going to be a flip over the y-axis. So negative outside, let me just write it like this. Here is f of x. If we put a sign out here, a negative, that is a flip over the x-axis. If we put a negative in here, that is a flip over the y-axis. So our first one we're going to look at here, the cube root of x. So cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, and we could also do negatives. Cube of negative 1 is negative 1, the cube of negative 8 is negative 2. So the graph kind of snakes through there, almost like an elongated S. And now we're going to flip everything over the x-axis. So when we put this negative out here, all the y values have now switched to negative. The origin won't change. That's still going to be 0, 0. But this point that was up here, positive 1, will now down be negative 1. This y value up here, positive 2, is now a negative 2. So that part of the graph has flipped under the x-axis. This part over here will flip up above it. So this point at negative 1 is now at negative 1, positive 1. This negative 2y value down here got flipped up to be a positive 2y value here. And the graph now looks reflected across that x-axis. Now here I already alluded to this, the reflection about the y-axis. If we negate the x value inside the function, remember the other one, it was outside here. If we negate inside the function, we reflect over the y-axis. So for each point on the graph of the original f of x, Negative xy is on the graph also. So let's see what we got here. Start with the good old root of x. We've done this a few times. Root of 0 is 0. Root of 1 is 1. Root of 4 is 2. And then we'd have to go off the graph to get up to 3. So it looks like this. We are now, again, the root of x is all up here in the first quadrant. When we negate inside, it's going to reflect us over top of the y-axis, or it'll reflect us about the y-axis. So here, in the last example, we flipped it over the x. Now we're going to flip it over the y-axis. So this point at 1, 1 is now negative 1, 1. Or this point that was at 4, 2 is now at negative 4, 2. Oops, so I guess I should put this over here, negative 1, 1, negative 4, 2. So now, instead of going up and to the right, our graph goes up and to the left. And you could always check a few by substituting, here if I put negative 4 into this function, I would have the root of negative 4. And those would turn positive, and that would be a value of 2. And that would be that point. All right, I believe these are the last 2 checkpoints for this video. The homework should be given out in class, a packet of notes, or excuse me, a packet of problems with plenty of graphs provided for you. So let's see here, checkpoint 4. We're starting with the absolute of x. So that's going to go from, I'll just put a point here, 0, 0. Oh, come on. 0, 0. And we'd go all the way out here to 8, 8. So the graph would look kind of like that. And then also from 0, 0 to negative 8, 8. So it's going to look like that V-shaped graph. Now here we are changing or reflecting over the y-axis. Outside is, it's reflection over the x-axis. We're going to change all our y values signs. So this point that was way up here at positive 8 is now going to be down here at negative 8. This one also at positive 8 is now down here at negative 8. And the origin will not change. Come on, why won't that work? There we go. So when we negate outside the function, it flips us over the x-axis. Here. Maybe I'll just do both of these on the same graph. So cube root of x, cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, and we can also cube our negatives. So this is the graph that kind of looks like that elongated S going through the origin. And now we are negating it inside the cube root, so that is going to reflect us across the y-axis. We're going to flip over the y-axis, so this point here is going to shift to the other side. This point over here is also going to jump across the y-axis, and these points will also flip over here. So red is the original function, and when we negate inside the function with the variable, that is going to flip us over the y-axis. And that's the end of the video. Tune in for day 2.